Uh, Hi, can we start now? Are everyone back?
Yeah, I think we should start. So welcome, sir. Welcome back.
Welcome, and thank you. Thanks a lot.
Ah,
So,
okay.
good evening, everyone, and welcome back. Okay. So, we will continue from yesterday where we left. Actually, we were doing data dimensionality reduction. And first of all, I would like to know, am I audible to everyone properly?
Yes, you are audible.
Okay, cool. So let me pick up from where I have left yesterday. So I'll just share my screen. Okay. So can everyone see my screen?
Yes, yes, yes.
Okay. So we actually yesterday we learned what is data dimensionality reduction, and we will learn one of the technique called principal component analysis. And I just explained like what LDA is in just a small briefing about LDA. So what is LDA basically? It's same like PCA, and in contrast to PCA, as PCA maximizes most of the variance in the data, LDA actually maximizes the separability between the two groups, as I have shown you in the example, wherein like I have a green class and I have a red class. And in PCA, if I draw an axis, if a new axis has been generated from the old one, so it will see the exact variance of the data, right? But in contrast to that, what LDA does is it's basically like draws, it generates another axis wherein like it focuses more on separability of the class. So in this diagram, we have seen like how green class is like separated from the red class, and how this is done. Basically, this is done by focusing like on the distances in the points in the within the group and between the group, right? So within the group mean within the red class group and green class group, and between class scatters means like between red and green class. Okay. So this was the mathematical formula how we actually find the scatter matrix, and then we do a dot product. We do a inverse of within class matrix, because we have to minimize that distances within the class, and we have to maximize the distance. Hence, we inverse the within class matrix. We do a dot product, and from there, we compute the eigenvectors and eigenvalues, and we understood yesterday like how eigenvectors and eigenvalues actually help in finding the more important linear discriminants, right? So this was the approach like we'll do right now, like doing the coding stuff. So I will just share the my notebooks. Okay, let me share the notebook on the Google Drive. I will just share the LDA part. So you can download the notebook from here. I've sent the, oh, sorry. I think I've sent the same link. Just wait, just wait. Yeah, this is the link. So everyone can download from this link the collab notebook. Okay. Uh, is that done? Like everyone downloaded the notebook? Should I start giving a demonstration of how LDA is computed using Python? Did you guys download it? Can someone reply on the group, please? Okay.
Yes, sir. It's getting downloaded. Yes, yes.
Okay. Okay. I will wait for 2 minutes. Not a problem. So I got couple of yes answers. So I assume like till now everyone has downloaded. So let's move ahead. Okay. So similarly, like it's same as a PCA, what we did earlier. I will just repeat all the steps, and then specific to the steps which are specific to LDA, I will just explain in detail. Okay. So here, like I'm importing all the libraries, required libraries, as you know, like Seaborn, from which we are. It's actually a plotting library also as well, and you have some inbuilt data set which you can use from the Seaborn library. And I have NumPy, Pandas, and Matplotlib again for plotting my graphs. Okay. So here I am again importing my iris data set from Seaborn library, which gets imported into my iris data variable. Okay. So if I see a head like top 5 records, I can say dot head method, and it will print me top 5 records from my data set. So as we can see from the data set that I have sepal length, sepal width, petal length, petal width, and species and as my dimensions in my data set. Okay. So so from this, like I just see like from when I use the property of the pandas data frame dot shape, I can see that I have 150 records and 5 features, 5 dimensions in my data frame. Okay. So up till here, like we have done the similar things for PCA as well. So I'm not getting into detail. So this basically gives me like the number of the unique species in my data set. So what we'll be doing in the further code, like we'll be considering this as my input variables or input features, and this will be my target variable or target feature. Okay. So sepal length, sepal width, petal width will be my input features on which I will make my model to actually train on, and it will predict the species of that particular flower. Okay. So this particular thing will give me the distinct species in my data set. Now what I am doing here is basically I am like splitting my input features and my output features, right? So this drop method will drop the species column. Axis equal to 1 means column. Okay, so it will drop the species column and it will store the result in variable X. Okay. And this variable y will store the column species from the iris dataset. Okay, so this particular line of code means like it's just selecting the species column from my iris dataset. So let me run the code from top. Like this is a head. So this actually gives me the shape, and this gives me the unique species, and this will actually split my input feature and the output feature. So when I do head, so so this particular head method will actually return me the top 5 records. So these are by basically X has only the input features in them, and then I like print Y. It will have again like the output features that are species of the flower, Setosa, versicolor, and virginica, right? So the first step, like as I told earlier also, like my machine, when I give data to machine to learn, so all the character data types, like in this case, the species have the data type of character. So machine actually doesn't understand characters. We have to convert those into numerical columns, right? So here we do level encoding of that particular categorical column. That is like my output variable. So here basically I'm converting my species column into, I'm label encoding my species column. So you can see like the Setosa has been converted to 0, the versicolor can be is converted to 1, and virginica has been converted to 2, right? So if I run this, like this is my output. So basically I have label encoded my categorical column. Okay. Now I'm doing a scaling of my input variables. So basically, like I'm normalizing my feature sets, right? My feature, which I have to give to my machine to learn, right? So this is basically like what does a standard scaler do? It's basically takes the value of my like say the feature, and it will subtract by mean value of that feature, and it will divide by the standard deviation, right? So this is how I scale my features, input features, right? So I'm using a standard scalar library from sklearn. Okay. So this object, what it does basically, it transforms my input features to a scaled values, right? So I'm calling fit and transform method, and I'm passing my x variable which has my input features. So I'm storing the output of this particular script to x scale variable, right? So now x scale variable has my scaled data, scaled features, right? So these are my scaled features. So you can see like it has all the features has been scaled to a particular range, to a comparable range. So basically the model should not get biased towards any one of the feature, right? Now, here again, I'm just printing that y. Okay, so just ignore that. Now over here, what I'm doing basically, I want to compute my scatter matrix, basically within class scatter matrix and between class data matrix, right? For that I need like number of features, I need number of unique classes. So I'm taking that in my variable, right? So x scale dot shape will return me the rows and the columns, right? So what I'm saying is that, so it will return me the list of rows and number of rows and columns. So the output will be something like this. I will just explain you. So the shape will give me the output as like 150 rows, okay, and 4 columns, right? So this will be of index 0 and this will be of index 1. So what I am taking, number of features, I am taking the index 1, so it will return 4 over here, right? So this will give me 4, and it will get stored in n features. And the class labels, like unique class labels, basically what I'm doing, I'm using a unique method of the numpy library. Okay, and I'm passing the y variable to it. So y has my output features, output labels, right? So it gives me the unique values of the y variable. So unique values are like 0, 1, and 2. Okay, so these I have stored in my variable to find the basically scatter matrix within the class and scatter matrix between the class. So for this formula, I need like overall mean. So I have just calculated the mean on the X scaled features. So basically I have the mean, and this is the mean for all the features, like all the 4 features I have, right? So I can just run this. Okay. So these are the mean values of each feature, right? So now my formula is basically like I have to like subtract the like to calculate the scatter matrix within the class. I have to like separate the value with the mean of that particular class, and raise to the power 2, and all those calculations I have to do, right? So for this, like what I'm doing initially, I'm just creating a zero matrix. So basically, like I'll be creating a 4 by 4 matrix which will have all zero values inside it, right? So that like whenever I calculate for each class, if I'm calculating the scatter matrix, I'll just add to this matrix. I'll keep on adding to this matrix. So as you can see from the previous this thing, like I have to sum up the scatter within each of the class, right? So I have to sum it up, right? Sorry. Okay. So for that, I am just creating a matrix of 0 by 0. Okay. And in the this thing for loop, what I am doing basically, I am like iterating it through each of the class labels, right? So my class labels, this class label variable has values 0, 1, and 2 over here, right? So what I am doing, I am iterating through each class labels, and I am calculating the within class scatter matrix, and I am calculating the between class scatter matrix, right? So as on it gets calculated, it will just get added to the above matrix, right? So I'm saying SW plus equal to, right? So this operator actually will add to the existing value of SW. So in the first iteration, my value will be like 000. So what happens, like it calculates the within class matrix and it will add those values to this particular variable. So now my matrix will have some value inside it, right? And in the second iteration, it will calculate for the class 1, and it will again add those scatter matrix to my existing matrix. Okay, so this is how I will get the scatter matrix for like within class and between the class scatter matrix, right? So if I print this, so this is my output after executing this for loop where I get the scatter matrix, right? So now the formula says like we have to inverse the within class scatter matrix and multiply it with dot product with it with between class scatter matrix, right? So I am using the numpy inverse function to inverse my uh, scatter matrix within scatter matrix, and then I'm doing a dot product of between class scatter matrix, right? And I store the result in my variable a, right? And after that, like I calculate the eigenvectors and eigenvalues of that variable a, and this is where I get my eigenvalues and eigenvectors as we did in the PCA, right? So the higher the eigenvalue signifies that this is the most important linear discriminant for my data. So over here, like as I can see, these two eigenvalues are of major importance because they are like higher than the other eigenvalues. As you can see, this is raised to 10 raised to minus 16 and 10 raised to minus 15. So it's almost equal to 0, right? So these two eigenvalues denotes that the first two components are most important linear discriminant components, right? So again, I do sorting. I have explained this yesterday also, like how I do sorting of the array of the eigenvalues, and I take top two eigenvalues and eigenvectors actually. So this is nothing. I'm just printing the eigenvalues and eigenvectors, and over here, what I'm doing, I'm taking the top two eigenvectors, which has the highest eigenvalues, and I'm taking into a variable called linear discriminants. These are my top two eigenvectors which I am taking. Okay, I'm printing those linear discriminant, and in the next step, what I'm doing basically, I'm like doing a dot product of my scale original data features with the linear discriminant. I'm getting the projected linear discriminant, the top two linear discriminants for my uh, data set. So if I see the shape of the data set, so you can clearly see that like it has been reduced from 4 features to 2 features. Okay, so if I again, if I want to see the visualization of the of my two principal, sorry, two linear discriminants, then I can plot a graph and I can clearly see that the projected graph, from the projected graph I can make out that these two linear discriminants are the most important and can represent whole data in just two linear discriminants. So they can classify better. Like rather using four features, we can just rely on two of the most important linear discriminants. Okay. Am I too fast? Because since we have done yesterday all those things, so I'm not explaining. I'm not getting into deep in all those things. I will just explaining the concepts of linear discriminants. Can someone reply? Like, is it okay? Like, I'm going in a right space, or I have to slow down? Okay. Okay. So all these calculations, we have an inbuilt library called sklearn, wherein we can have a object called linear discriminant analysis. Okay. So in this example, in this cell, what I'm doing, I'm using that library and uh, I'm transforming my features. I'm transforming my data set into a two linear discriminant data set. So what I'm doing basically, I'm creating an object of LDA, linear discriminant analysis, as I have given the alias as LDA. So I'm creating an object of LDA. Okay, and here I'm calling that function called fit transform of the LDA object, and I am passing the x value, the input feature and the output feature. As you know that LDA is a supervised algo, you have to provide the class labels. You have to provide your output feature. It's a kind of supervised algorithm, right? So what it does, it basically does all what we have done. It maximizes the difference between the class, and it minimizes the scatter within the class. It finds the eigenvalues, eigenvectors. It actually orders them in the descending order, and the top two, it returns the top two reduced features, which you can see here on in my print statement. I am printing the top two features, right? So when I do some visualization on this particular data, which my LDA method has returned, I can see that it clearly distinguish between the classes. Like it clearly classifies my classes. Okay. So till here, it is more similar like PCA. We have what we have done yesterday, and only bit difference is like it calculates the within class data and between class data, and that's where it actually focuses more on the class separation rather on focusing on the variance of the data. Okay, so now let's test my data. Let's test how the model performs, like when I give the whole data and when I give the linear discriminant features. Okay, so here what I'm doing basically, I'm taking the raw data which I had, like the raw data which I have had in the variable x and variable y. Okay, so in machine learning world, when you have a sample of data, you have to actually split them into a training data and the testing data, because no one will give you, like, if they give you a testing data separately, then it's fine. If suppose, let's say, at the time of validating your model, you want a test data, so whatever data you have to split that into a training data and the test data, right? So over here in this cell, you can see I am using the sklearn model selection library, and in that I have an object called train test split. So now what this train test split does is basically, I'm I'm calling this train test split, and I'm passing it the input feature and the output feature, right? So input features are there in my variable x, and output feature is there in my variable y, right? And I'm saying test size is of 0.2. So what does this mean is like from the given data, from the given set of data, like I want 20% of the data to be separated as a test data, and rest 80% of the data I want it to be as a trained data, training data, right? So what exactly it will return? Four arrays, right? Four matrices basically. And one will be like two of the input feature and two of the output feature. So basically, it will return the 80% of the input feature in X train. I'm taking that particular 80% in the X train variable, and the rest 20% of my input feature into X test variable. Okay. Similarly, for my output feature, I'm taking 80% of the data in the Y train variable and rest 20% in the Y test variable. Okay. So if I run this, okay, and let's say I just want to see the count of data. So if I see X train, so you can see the count like from 150, I got like in my trained in my X trained variable, I have 120 record. That is 80% of the original data set, right? And remaining 20% has been in X test variable. Okay, so this is how we actually split. Random state zero means like I'm not using any seed to randomize my data. And it's just picking in a similar manner. Like if you specify some seed, it will use that seed to actually randomize your data. Okay, so this is how we split for the train and test state, right? In this particular cell, what I am doing, I am like using random forest classifier algorithm to actually train my model. Okay, so this I am importing from the library sklearn ensemble, okay, wherein they have an inbuilt algorithm for random forest classifier. So this particular object, what I am doing, I am creating a classifier object. Okay, my variable name is classifier. I am creating an object of random forest classifier. So in this random forest classifier object, I am passing a parameter called max depth equal to 2, right? So that means like the trees in the random forest will be of a level 2. Okay. And similarly, random state is just a seed I'm passing to randomize the data, right? So now I have a classifier object which is of type random forest classifier, right? Now I am calling the function fit to actually train my model on the training data. So I am passing, since it's a supervised learning, I am passing the training input features also and the output feature as well, right? So this statement actually trains my model. Okay, now I want to test my model, right? So what I do basically is like I have to pass the X test variable, which has the input variables, input features for the testing purpose. So I have the testing data which I have not exposed to the model while training, right? So testing data you never expose to your model, then only like it will be thoroughly tested, right? If you expose those data to the testing to the model at the time of training, then the model will always know like, okay, this data, if this is the case, then this is the class, and so on, right? So testing data you never expose to the model while at the time of training. So now, since my model has been trained on the training data, I will just test it on the testing data. So I will pass the X test variable which has the testing data inside it, right? So, and whatever prediction the model has done, it will store in my variable ypred. Okay. So here, when I execute this statement, my model actually predicted, right? So now I have all the values in my ypred variable. Now from the matrix, now we can actually since it's a classifier model, I can actually have a confusion matrix, right? So I hope like everyone understands what confusion matrix is. Okay, so I'm importing a library called confusion matrix, and I'm passing the y test and the y pred. What is y pred? Y pred is what my model has predicted, right? And y test is what actually the value is. So I already like splitted the values, like I already know the values of my predictions, right? My actual values, and these are my predicted values which the model has predicted. So I am comparing both these values, right? So my confusion matrix will look something like this. So what you can see from here, so overall, like I had 30 records in my test data, right? So 11 were of species Setosa, and 13 were of species versicolor, and 6 were of species virginica, right? So overall, my testing data had 30 records. So what happened? Basically, my model predicted, and all the 11 species of Setosa, it has predicted correctly. And similarly, for versicolor also, it predicted correctly. And for virginica also, it predicted very much correctly. So the accuracy level was 1%, like 100%, sorry. Since here the data is like very small, so basically you will see like okay, 100%. It's never the case like we get 100% accuracy. Over here, the data size is very small, so that's why you will not see any difference like in the accuracy level. So basically, like the accuracy level over here is 100%. So now what I'm doing, like in the next step, I'm like taking my two linear discriminants. Okay, so same thing I'm doing. I'm like splitting the x projected my projected data from the linear discriminants which I had, and I'm having the y variable, the output variable, right? So over here, I'm again splitting my linear discriminant, the two linear discriminants which I have, and their respective output variables into train test split of 80-20%, right? So here again, I'm like creating an object called classifier, random forest classifier, and with a max depth of 2, and with a random state 0, right? And again, I'm like giving those data, that projected data, that linear discriminant, what I have done, the using the LDA with the input feature which I got, I am providing it to my model to actually train on, right? And here I am like doing a prediction similarly, which I did in the earlier case when I actually fed the raw data to my model, right? So let me run this code. Okay, now I am like printing the confusion matrix and the accuracy. So as you can see, like as my features reduced, like my features reduced from like 4 to 1, the accuracy level still remain like still is the same, right? So that means like my whole data can be actually represented by only two linear discriminants, linear two linear discriminants, that is two most important features. Okay, so this is the technique like we use for LDA to actually reduce our dimensions. Okay, so I think everyone got it, right? Is Was that okay? Like, do you have any questions or any queries to ask about LDA? Can someone reply? Like, can someone text me? Shall I go to next slide or next? Okay. So I have another. I have another notebook which actually did a small visual comparison uh, between PCA and LDA. I'm just sharing that with you guys. So there is one question: what is bias for choosing next depth? I couldn't get the question though. Like, can you just um, okay? Is this question not related to me or like? Okay, I will just share the link of another notebook wherein I have did some coding demonstration of difference between LDA and PCA. Can you just open this book, notebook? Guys, did you downloaded the notebook? Can someone reply from the book? Yeah. Okay, I'll just wait
So
for
yes,
two
sir.
minutes. Yes. Yes, I will just give 2 minutes. Like, I'll wait for 2 minutes. Not a problem. Download it. Okay. So here I've just did a small visualization comparison between PCA and LDA. So here I'm just plotting a graph. So basically what I did, like I'm taking the same iris data set. Okay. And here what I am doing basically is I am actually like taking a data features, input features in X variable and output feature in Y variable. Okay, and here I am taking the target names. Okay, so this basically has the numerical data and this has the categorical data. So basically, it's an inbuilt property of the iris data set, which is there in SK11. Okay, so I'm using that particular function to actually get the data. Okay, then I'm creating an object called PCA with two components. Okay, and I'm storing the transform data of PCA into x underscore r variable, and then I'm doing a linear discriminant analysis. I'm calling this particular object and passing the n components equal to 2. So and I'm calling a transform function wherein like I'm storing the output in x underscore r2. So my r will be PCA, my r2 will be LDA. Okay. So now I'm just plotting the graph. I'm giving the colors to different classes. My class name is Setosa, Versicolor, and Virginica. So I'm giving them the colors navy blue, turquoise, and dark orange. Okay. So I'm using this for loop to actually plot the points uh, on my graph. So what happens basically is I'll just execute it and I'll show you. Okay. So it actually iterates 3 times because I have 3 colors in the. This will return me the tuple of three list of 3 tuples. Okay, so and I'm like taking the values inside this. So for once for Setosa it will take color as navy blue, and second time it will take a turquoise and dark orange, and it will iterate and it will plot the graph. So here you can see that the variance is basically like 90% plus that is 5%, that is like 97% explained variance in PCA. So you can see like the classification in the PCA is not that better than the LDA. So LDA is mostly used for classification. So this is how like this is what the difference between PCA and LDA is. So PCA more likely is used like when you have like beneficial, actually when you apply, like you don't have a label or you don't have a output variable. Basically it's a unsupervised learning, so that time you can use PCA. If you have labels, you have classes to where you can classify, you can use LDA. Okay. So in case of uniformly distributed data, LDA almost always perform better than PCA. And however, if the data is highly skewed, then you use PCA. Actually, that will perform better. So this is basically like how LDA and PCA actually are actually it's advantage, like maximum advantage they give in this particular scenario. Okay. So guys, did you get up till here? Is everyone able to run the code and see the execution? So till now, I hope like everyone is clear about like PCA and LDA. Let us move to the next topic, that is SVD. Okay, that is single value decomposition. I will share you the link of my notebook. So you people can download the link from here. Okay. Once downloaded, can you let me know like it's downloaded so that I can start with SVD? Okay. So I hope like everyone is done with the downloading. So let us move to the next notebook, that is of SVD, that is singular value decomposition. Okay. So basically it's a kind of matrix decomposition which is widely used in a method of dimensionality reduction. So it's one of the best method of like dimensionality reduction. So its result is actually a matrix of a low rank, which actually is said to approximate the original matrix. So basically, like the same funda, like its more important matrix will be retained, right? So where singular value decomposition is used, where SVD is used, basically it's used where the data is you have a sparse data. What do you mean by sparse data? Let me explain you what we mean by sparse data. Let's say I have let's say I have a document list, right? Let's say I have 10,000 of documents, right? Let's say 1, 2, 3, 4, 5 till I have 10,000 documents, right? So now what happens, like after like doing after removing the uh, important words from it, after filtering out the important words from it, we create a dimension. Let's say the dimensions like for 10,000 10,000 documents. Let's say each document has more important like 10 words each document has. So my dimensions will be like around 1 lakh dimensions, right? So each unique words will become my dimensions, right? So in this case, what will happen? Like let's say for document number one, so only 10 records will have 10 columns will have value. Let's say like one of the word I have in this document one, so I'll mark it as one. This word I have in the document, so I will mark it as one. And this word I have in the document, I will mark it as one. And all the rest of the document will have zero values because those words doesn't appear in that document, right? So this particular kind of matrix is called a sparse matrix or sparse data. So in this kind of scenario, you can use SVD, singular value decomposition, to actually reduce your dimensions. Okay. So so in this example, like I'll just move to coding the in to how to code the SVD in Python. So in this example, what we do basically, we'll take an example of a gapminder data, which you can find from the carpentry's website. This is the URL of the website from where I have actually downloaded the data. Okay. So let's move like how to do SVD. Okay. So we'll be using a NumPy function, SVD function, to code SVD. Okay, so in this first cell, what I am doing basically is I am importing the libraries, which you already know, the pandas library, the NumPy library, and the for plotting the graph, that's a matplotlib library, and a seaborn library, right? So in this particular cell, so if I run this cell, so in this particular cell, what I am doing basically, I am like downloading the data into my data frame. I am using a pandas dot read sv read dot read underscore csv function, okay, to read the data from the URL. So this is my URL I have stored in the data underscore URL variable, and I am calling that variable by executing the method called readCSV, and the data from that particular URL gets stored in my gapminder variable. Okay, so if I run this, it will store the data in the gapminder database, and here I am just selecting the top three records from my gapminder data frame. So you can see like my gapminder data frame has 38 columns inside it, 38 features. Okay, so what are the features? Like my data set has continent, country, okay, GDP per capita, starting from 1952, and it's like from 1952 onwards, I have till 1987, or might be more than that. So here you can see dot dot. So it is not able to display all the columns. So basically, it's like displaying the first 10 columns and the last 10 columns. Okay. So this is what I have in my gapminder data frame. Okay, so if I check the shape of my data, so I'm seeing like I have 142 records and 38 columns. So the data is of 142 countries across the continents. Okay, and there are 38 columns which I have already explained. So if I want to see the whole column list, I can check the property dot columns property of the gapminder, and it will list down the columns in my data frame, right? So now I can see that I have a column called continent, country. The columns are GDP per capita. So this is basically starting from 1952 to 2007, in the space of like 5 years. So every 5 years ka data I have per capita per capita income of that particular country. Okay, then the life expectancy from starting from 1952 onwards till 2007. So what is the average life expectancy in that particular country? Okay, and then I have a population of that particular country in a column. Okay, so can everyone execute till here? Everyone is done executing till here?
Yes, sir.
Okay. So now I just want to analyze the data of a continent. I just want to analyze the life expectancy data, and for the continents like Africa and Europe, I don't want to analyze whole of the data. So what I'm doing here in the next cell, I'm filtering out all those columns. So here, if you can see what I'm doing, I'm using the .loc method for this the pandas method, in which this is used for actually slicing the data frame. So what I'm telling is that it needs two parameters. One is number of rows, the rows and the columns, right? So in this particular rows, this is basically the how we slice the list. This is exactly the same. So if I put colon, then it's like all the all the values, right? So here the first means like the all the rows. So basically this column colon denotes all the rows in my data set, and this then I'm putting a comma and passing the other parameter. So other parameter I'm passing the list of columns which I want to actually filter out, right? So what does this do is basically this checks, this is a regular expression, okay? So I'm saying like wherever the column name, so this particular thing will give me the column name, and this will convert that into a string, and I'm actually calling the contains method of the string. So this contains method will check whether the column name starts with life. Okay, start with life, life, or. So this is my or operator. Okay, and I'm saying or the column name starts with. So this caret over here, it says starts with, right? The regex caret means starts with. So I'm saying or it starts with C. So all the columns which start with C or which start with life, I'm like filtering out, and I'm putting into the variable called life expectancy. Okay. So if I execute this particular cell, I can see that my columns, continent, country, and all the life expectancy columns have been filtered out and stored in my life expectancy variable, life exp data frame. Okay. So now what I'm doing basically, I'm filtering, I'm like splitting my categorical columns into another data frame, and I am splitting my categorical and numerical columns, right? So here what I'm doing basically, I'm like first what I will do, I will filter out the rows, because I just want to do classification between the two continents, Africa and Europe. So here what I am doing basically, I am using is in function to actually filter out my rows. So I'm saying like the rows where the continent column. Okay, so in my life exp data frame, and continent column is in Africa and Europe, then filter out those rows, right? So this will return me the indexes of all the rows, and then I'm saying life expectancy and then the indexes of all those rows. So it will filter out those records which are having continent as Africa and Europe, right? So now I have a data frame which actually contains only the data of two continents, that is Africa and Europe, right? So let me run this particular cell. Okay. So you can see like I have 82 rows and 14 columns in it. Okay. Hmm. So now if I move ahead, like what I'm doing over here is I'm splitting my country column and country and continent column in a separate metadata. So here I am saying again the same function I am using contains, and the column which start with C, right? So my country and continent column will get separated out, and it will the result I am storing in this particular variable life exp underscore meta. Okay, and when I do head of that particular variable, I can see my continent and country column. And from the original data set, I am just dropping that continent and country column, right, in this particular set. So if I run this, I can see like now my life exp underscore ae data frame has only life expectancy columns, okay, the numerical columns. So I have separated out the categorical column, the country and continent, and I have like separated out my input features, which are life expectancy columns, okay. So now I move ahead, and I'm like doing a normalization. So again, like I'm not using that function, standard scalar function. I'm like doing it manually. So what I am doing, I'm like taking the values of each of the each value and subtracting it by the mean of that particular column. Okay, and then dividing by standard scalar, sorry, standard deviation of that particular column, right? So here I get the I have normalized my data, right? Now if I check the shape, I can see like I have 82 column. Now I have the scale data in my life expectancy AE underscore scale, right? It will be the data of only Africa and Europe. Now I am using dot svd like svd function of numpy, which will return me three matrices. One will be the leftmost matrices, which actually returns me the vectors, and the singular vector, which will actually give the significance of my dimensions. So basically, when I run this, and I print the matrices, this is what the shape of the matrices is. So the U matrices will actually have 82 into 82, that is basically number of rows, and the V matrix will have 12 into 12, 12 by 12 matrix, which is number of columns, right? So basically the same thing what we did in PCA and LDA, the same thing we are doing over here. So what we are doing, we are taking the singular matrix, and we are explaining the variance inside my data, right? So over here, what I'm doing, I'm like printing the S matrix and printing the S matrix over here. And for variance explained, what I am doing basically, I am like the formula is like this value ka square divided by sum of the value ka square. So basically, like what I'm doing, I'm taking a single first value of that vector. So let me run this code, and I can show you then. Okay, so over here, variance explained, you can see like I have printed it over here. So this is my S matrix. Okay, so this, it has given me for all the columns I have in my table, 12 columns, so 12 singular values it has given. The highest one gives me the most significant it is the most significant component, like a PCA, you can say. So PCA under hood, actually it uses the same SVD method to actually find the principal component. Okay, so over here, like explain variance can give you the share, I'm basically what I'm doing. Basically, I'm squaring the first value, and then I am dividing it by the square of all the values. So why we are squaring it? Basically, like if the value is negative, it should not negate. So basically, that's the reason we need to square the values, right? So this actually gives me the explained variance in the data. So you can see from this variance explained that the first two components can actually explain my whole data, what I had in my raw data, which has been like explained by 12 features. Initially, I had 12 features in my data, all the life expectancy columns, that can be actually explained with only two principal components, you can say, two components. Okay, so this will denote my 98% of my variance, right? So if I see a visual representation of this SVD, I can clearly see that the first component actually has a variance of 94%, and the second component has a variance of 4%. Okay, so this is how like you can actually reduce the data set using SVD. Okay, so I'll run this cell, and this is basically I'm converting my components, the components which I got it from here, the variance which I got it from here. I am taking the matrix U matrix, and I'm taking the first two columns of that U matrix. Okay, and I'm like converting that into a data frame. So what does this particular line does is basically it takes the matrix as the input columns. Okay, it takes a continent name from the like we have a metadata stored in this particular variable, right? So it takes the continent name and it take columns as a label. So I am giving the label to my columns which are there in the matrix U, right? So I am forming this kind of data frame. So what it happens basically is first time it considers these continents as the index, okay, index column. So basically I'm doing an index on the continent. So once I reset my index in data frame in pandas, it will reset the index and it will give its own index like 0, 1, 2, 3, but the column name will still remain as index. So I am just renaming the column name from index to continent. Okay, so this is what I'm doing. I'm just, in a simple words, like I'm just converting my first two principal components in a pandas data frame to actually do the further visualization. Okay, so I've executed this particular cell. Okay, so did you guys understand this particular line of code? Was I clear on that? Okay, okay. So this is how I like convert my matrix into a pandas data frame, and I got this data frame which is having like only two dimensions right now. Okay, so if I do a visual representation of those two dimensions, I can clearly see that it actually create a good classification for my data. Like all the blacks are in are of African continent, and all reds are of Europe continent. So this is how like SVD actually helps in uh, reducing my dimensions, reducing the dimension, and making my model to perform well. Okay, so again I have another there's a short form to do SVD also. So basically again the sklearn library. So till now you have seen like sklearn library is like most useful in all these data reduction techniques, right? So in that you have another object called truncated SVD, which actually is a singular value decomposition. So you can use this particular object to actually do the SVD. So here I am like taking first two components of my data set. So I am passing the scale data to my fit and transform method of that SVD object which I have created over here. Okay, so I just executed this particular cell. So when I execute this cell, so what it does, it gives me the variation, this singular value which we got from the vector s, right? When we calculated upstairs, the vector s was there, right? Here, the s matrix. So you can see like the singular values over here for all. It will return for only first two components. By default it returns for two components. So you have to basically optimize, and you have to check. So if I give 3 over here, it will return me for, sorry, it will return me for three components. So if I say 3, it will return the singular values for three components, right? But by default, it returns for two components. If you don't specify this parameter, it will return for first two components. Okay. So you can see the values of my first two singular values from the SVD function, and these are the values. This is the highest value. This is the second highest value. So that denotes like my first component is the most important, and the second component is the second most important uh, component. Okay. Now, this particular property explained variance ratio. This gives me the variance uh, across your components. So basically, the first component has a variance of 94%, and the second component has the variation of 4%, right? So, and this will give me the variance sum. So basically, my first two components, if I sum up, they give a variance of 98%, right? So this is how like SVD is done using sklearn. So in a similar way, like I'm just creating a Panda data frame out of my SVD, whatever features it has written. It has written me a array matrix. So I'm just converting that into a Panda frame to actually visualize the data in a graphical manner. So here I am again like plotting a graph, and I can see like it has discriminated my categories very well, right? So guys, this is how like we can do dimensional reductions. Okay, so we have covered like PCA, LDA, and SVD. So these are like most important technique for actually data reduction, dimension reduction. Okay, so do you guys have any questions or any queries related to it? Guys, do you have any questions? Can someone reply on the chat? Okay. Cool. So the last topic for the day is about imbalanced data set. So what I will do, I will share you my notebook about imbalanced data set. Okay. So here comes the link for the notebook. Okay. So guys, can you just download this notebook? So once you download it, I will like go ahead and explain you the code in that. Just let me know once you download it. Okay, so I got two replies saying done. So I will do one thing. I'll just start with unbalanced data set. Okay. So what is imbalanced data set? So let me explain what imbalanced data set means. Okay, first. So let's say I have a data set. Okay, wherein let's say this data set is of like about detecting cancers, right? So let's say I have tested the patient, and I have all the dimensions as their reports, and as their like whatever type of reports they get, whatever values in this particular cells, and in the end uh, I have this output variable which says whether the guy, like whether the person has been tested has cancer or not. Let's say yes or no, right? So let's say if you want to build a model on this data set. So usually what happens basically, what is imbalanced data set? So let's say like in this data set, you have most of the patient has been like they don't have cancer. Say no. So most of the data, most of the samples have the output variables as not having cancer, right? And there might be like around, let's say like I have 10,000 records in in this data set, and I have, let's say, around 9,900 records which says the patient are not suffering from cancer. Okay, and 100 100 data samples are having patients which are suffering from the cancer. Okay, so now in this case, what happens basically when I actually give this data to machine to learn on, what happens, like, since this is a imbalanced data, this is called imbalanced data, where your majority class will have the most number of samples in your data set, and your minority class will have very less number of data set. This is called imbalanced data set. So what happens, the challenge over here is that in machine learning it's very difficult to actually predict the minority class, because let's say if I provide this data, so as we have seen that while training our model we have to split the data. Let's say if we split the data into 80-20%, there might be a possibility that in the training data that 99% data set is of majority class. So what will happen, like when I test the model, okay, so if my model, let's say when I test the model and my testing data, let's say it has 10 records, total it had like 100 records, out of which 10 are my minor class records. So when I actually test this model, okay, test this data on my model which has been trained mostly on the majority class data, what will happen, it will predict whole test data as patient having no cancer, right? So it will predict that it is N category. And the accuracy, if I calculate the accuracy, what will be the accuracy? The accuracy will be again 90%, right? Because 90% of the time it has predicted well, right? It has predicted correctly, because since the data you have is basically like most of the data are of majority class. So since the accuracy level is like 90%, so I'll be under the impression like the model which I've trained is doing very good, like the performance is very good. But in real life, it is actually a disaster for the model, right? So this kind of data is called imbalanced data. Okay. So what are the what is the solution for this? So one approach can be like, what you can do basically is you can actually take the same number of data set as the minority class. Let's say I have 100 records of the minority class, I have 9,900 of the majority class, right? So what I can do while training, I can take 100 records of the minority class, that is Y, and same number of records of the majority class, that is N, and I can take 100 records of the majority class, and I can actually take this sample and I can train on this data. So this is one of the way like you can do it, right? But in this particular method, what happens basically, you lose out the information that this particular class is your majority class. So your model actually lose the information of this particular information that this class is my majority class. Okay, so this is one of the drawback of like taking the equal number of data samples. Okay, so one of the other method of actually balancing your data set is basically like SMORT method. What you call is SMORT method. What does SMORT means? SMORT means synthetic minority synthetic minority. This is uh, creation of the data set technique. Okay, So synthetic minority technique, wherein you generate synthetic records of the minority class. So what does that means? Basically, let's say you have a Euclidean space, you have a vector space, okay, wherein you have like, let's say, these points of your minority class. So what happens basically, basically what happens is, like, it will consider k nearest neighbors, and it will generate somewhere here a synthetic record for your minority class. So this is how it generates the synthetic records for your minority class. So this mode means synthetic minority oversampling technique. So you oversample your minority class records, okay, oversample your minority samples, okay, and in the same time, what you can do, basically, you can undersample your majority class. So this is your majority class, and so you can undersample that. So you can undersample in such a way, like you just in such a way that your minority class is like 1% or 10% of your majority class. What does that means? Like if I consider, let's say, if I say like my minority class sample should be of 50% of my majority class. So if I am generating, let's say, 100 samples, synthetic samples of my minority class, then what I can say, I can undersample in such a way my majority class that I will just take 200 records, right? So in this case, I will be having like 100 records of the minority class and 200 records of the majority class. So in this method, like you will not be losing the information also, like this is your majority class, and the performance of my model, which has been trained on this kind of balanced data set, will be good enough to actually make the prediction for the minority class. Okay, so let's go ahead and I will do the demo of the code, okay, of imbalanced data set. Okay, so this is the library, like which I have actually installed. So I think this will be there in Colab. So IMB learn. Okay, and so from here, the next cell here, I am importing my pandas to actually load the data frame. Okay, then I have a plotting libraries, Seaborn and Matplotlib. Okay, and here I have my classifiers. So I'll be testing my both the samples, like the original data and the sample, the balanced data set on all these models, logistic regression and SVC and k nearest neighbor classifier and decision tree classifier. Okay, so uh, these are my libraries which I have imported for my classifier. So we'll be testing on these models. Okay. Then I have like this particular object called stratified k-fold, which I will explain you in the later in the code. What does it do? So basically, it's used for splitting my data set into training and test model. Okay, and this basically the smooth library which I'm importing from IMB Learn. This is used for creating a synthetic records for my minority class. Okay, so this is like smooth is like synthetic minority oversampling technique. Okay, so basically it will oversample my minority class samples, and this is like undersampler object which will undersample my majority class uh, samples. Okay, then I am like importing the pipeline, and this is just like I am suppressing the warning, any kind of warning I am getting. Okay, so the data set which I am using right now, it's in my drive. So it's of a credit card data set. So basically I'll be like detecting whether whether the transactions are fraud or not. So let me share you the data set as well. Okay, so I will just share the data set. Just wait. It's there on my PC, so I just forgot to actually share it. So, you people can actually download the data set from here. Okay. So let me know once the data has been downloaded. So I will proceed ahead. So I'm not getting it, Dr. Nirbhay Chaubey. You're saying it seems file name is same. So what do you mean by that? Yeah, the file name is same, right? Which,
Yes, yes, file name is the same.
yeah, yeah. Oh, I've shared the previous link over. Oh, sorry. I'm really sorry. I think this is the one. Yeah, I have shared the previous link. Can you guys download from here? Okay. So I have stored in a particular drive. So you can also store somewhere in the drive and actually give the path to download that into a Panda data frame. Okay. So this is just a read CSV method which I am calling to actually load my CSV file into a data frame, right? So if I execute this, it has actually downloaded my CSV file into a data frame. So here, like if I'm doing a head of my data frame df, so I can see like here actually I have already scaled the amount and the time column. Okay, so this has been already scaled, these two columns. Okay, and even the other features has been scaled. So basically you can see like I have 31 dimensions, and this actually I'm just printing head, so it gave me 5 rows, right? So if I check the shape of the data set, you can see that my data set has 2,84,807 samples of the credit card transactions, right? And 31 dimensions I have. Okay, so I think I'm clear till this end, right? So what does value counts give me? So value counts give me like I'm specifying the column name class. So let me just see what exactly I have in my data set. So I have all these features: scale amount, scale time, and the feature from V1 to V28. And then lastly, I have class wherein it specifies whether the transaction is fraudulent or not. So basically, if it's fraudulent, it's 1, and if it's not fraudulent, it's 0. Okay. So when I see the value counts of this particular column, so what it gives basically, it gives me the number of count per class. Okay. So now my class are 0 and 1. 0 means not fraudulent, and 1 means fraudulent transactions, right? So you can see from here, like the number of class 0 is more, the number of samples of class 0 is like very much higher than the number of samples of class 1, right? So number of records for class 0 is 2,84,315, and number of rows for the class 1 is 492 records only. Okay. So when I check the percentage, okay, so I can clearly see that the no fraud cases are, the samples in my data set are 99.83%. Okay, and the fraud cases in my transaction are only 0.17. Okay, so I'll just explain this code. So basically, you know what this particular code actually returns the value count. So value count will return me two rows with and two columns, right? So what I am doing basically, I am taking so I want to calculate the percentage of no frauds. So I'm saying like the zeroth index of my data frame. So zeroth index is this. So I'm taking this value, okay, and I'm like dividing it by the length of the DF. So length of the DF will be sum of this and this, right? So into 100, and I am rounding it off to the two decimal places. So this will return me 99.83% of my data set. And fraud data set, it's the same thing I'm doing. Like I'm just getting the first, instead of zeroth record, I'm just taking the first record, right? And it will return me 17%. Okay. So from this, I can clearly see that my data set is very imbalanced. So my majority class is no fraud and my minority class is fraud class, right? So if I give this data set to my machine to learn, as I explained earlier, it will have it will be like, it will actually like for predicting the minority class, it will not be that perfect. So it can happen that the whole test we might be doing, it might predict that the whole testing on the data set which you are doing is of a no fraud case, and that will be like my accuracy level will be almost 99%, right? So for this, I'm just for the same, I'm just doing a graphical representation. Okay, so you can see like my data set, like it's more than the majority class is more than 27%, 27 lakhs. And similarly, like you can see like there is hardly any records of minority class, right? Okay, so the first method which we discussed basically is like taking the whole minority record class, minority class records, right? So let's say I have a record, as we have seen, how many number of records we had? We had 492 records of the minority class. Okay, so what we do basically, we take the whole record of the minority class that is of 1, and out of 27 lakhs, 28 lakhs 430 43 4315 records, we are taking 492 records of the majority class as well. Okay, so here what I am doing, I am taking in a variable fraud df, I am taking all the records of the class where the value is 1, right? So this will give me the index of the data frame where the value of the column class is 1, right? And then I am filtering all those records, passing that indexes to this particular loc function, which will return.
Parvez sir, you are not audible. Hello? Parvez sir, some audio issue. Yeah. Okay, I'll call him. Yeah, he understood. He's logging back. Okay. Yes, sir. क्या हुआ? He's joining back. There's a power cut at his place, so he's joining through some other network. Just wait for 2 minutes. Pramod sir, are you there? Pramod sir. Pramod sir, in meantime, what you can do is, Pramod sir,
Yes, sir. Yes, sir.
meantime, what you can do is, you can tell the participants about tomorrow's assignment, no, your assignment. Can you explain? Because,
Yes, sir. Yes.
yeah, Parvez sir has got a power cut, so he's joining through some other device. So it may take 1 or
Okay.
2
No.
minutes to explain about
Yes. Yes.
tomorrow's assignment. No?
Yeah.
Go
Sure.
ahead.
Sure. Sure. Okay. Dear all participants, we have seen, we have gone through SCADA tutorial with various examples, object-oriented features, functional features, and all control structures, inheritance, then how to create object, then various object-oriented operations, right? So based on that simple constructor, based on that, I will upload a quiz within 15 minutes as your session gets over on a Moodle, right? And what you have to do basically, you have to create a, so that I will just explain here, and regarding all details also I will upload on a Moodle. What you have to do, so basically you have to create a class of your personal information, right? Your biography, you have to create a constructor. The example which you have seen, the code is already there. You have to modify the code according to the conditions which I will be giving in that particular explanation for a particular code. So what you have to do, you have to print your name, your email ID, your mobile number, your designation, your experience, right? And other parameters if you want to add with respect to that particular given conditions. It is optional. If you want to add that parameters, you can add that, right? And you have to use constructor overloading in that, right? And if you refer the code which I have given
which I have uploaded on a Moodle, right? Using that also you can means you won't find any difficulties in that. And if you find any difficulties, then you can send me a mail on my mail ID. I will revert to that particular mail. But I don't think if you will find any difficulties in that, right? So you have to create two constructors, right? One constructor will will print your details of your name and your designation, and other constructor will print all other remaining details, right? So that conditions also I will mention, and you have to execute this particular code with your name and everything, whatever you will add there, right? And you can upload on Scala Eclipse IDE, as we had discussed. If you don't want to execute on Scala Eclipse IDE, then you can execute it on online link which I have given on that link is also uploaded on a Moodle, right? So that also you can execute, and you have to that code and screenshot of execution. Okay, you have to attach in a particular file, and you have to upload it on a Moodle. That uploading link also available on a Moodle. And apart from this, in that doc only you have to add differences between Java and Scala, right? 4 or 5 points you have to add. So these are the two questions you have to do, and you have to complete it this particular assignments before tomorrow evening 6:30, or before tomorrow 9 p.m. You have to upload it. Then accordingly we will grade it on a Moodle. Okay, so any difficulties? So whatever I have explained, that everything I will put in a detail on a Moodle also, so that you won't get any difficulties, right? अगर कुछ difficulties आपको understanding में है तो अभी मुझे बताओ, so that I can explain it. You have to create a simple class, और अगर आपका execution आपने Scala Eclipse install नहीं किया, then also it is fine, because I have already given you a ready-made link of Scala, official Scala link, राइट, दैट इज अवेलेबल ऑन अ Moodle. सो आप जो कोड लिखने के बाद सेम कोड आप अगर उसको टर्मिनल में डालते हो तो यू विल गेट अ आउटपुट. जस्ट यू हैव टू क्लिक ऑन अ सेव बटन सो दैट यू विल गेट अ आउटपुट. अलॉन्ग विद दिस आपका ना, लेकिन योर पर्सनल डिटेल्स must be visible in output. If you are copy pasting it, then it will be difficult for you. You will get a less grade in this particular assignment. Okay, done.
Pramod sir, it's okay.
Okay, sir.
but this enough. They'll understand. ठीक है, it's okay. अच्छा, किसी ने कमेंट किया है कि प्लीज एक्सटेंड द सबमिशन डेट. Madam, only 1 day is remaining for workshop. Tomorrow is only the day. After that, it's next day is a validatory session and your exam. Please understand that Saturday's exam is compulsory. Don't miss that.
Sir, I have a question. Can I ask?
Yes, please go ahead.
Sir, I've got the mail on third day for joining the program.
Yeah, that is okay. That is okay. I understood your question. It is okay, sir. You give this assignment and Saturday's quiz. Okay, Saturday's.
Okay.
Okay, it's okay. No problem. You missed first quiz, na? First one or two. It's okay. That's why we are doing a continuous assessment, so that if anybody misses a few quizzes, it's okay, perfectly fine. Finally, it has to be out of 100, 60% marks should be there. That kind of gradation is there. Okay. But it should not happen that somebody has not given the examinations at all. Then we are not going to, definitely we are not going to release the certificate. Okay. So please, you're not given, anybody has not given, complete this assignment, and Saturday's assignment must. Sir, Parvez sir, what happened? I can see your name.
Come on, sir.
Sir,
I have
again.
one doubt. Sorry to interrupt.
Just a minute. Parvez sir, sir का नाम तो दिख रहा है, but sir, I don't know. Yes, Apeksha madam. Madam, I can't hear you. Madam, not audible.
Am I audible?
Yes.
Pramod sir just mentioned that we need to attach the output of our code. So is the output should be in the form of screenshot, or we need to copy paste it like a text?
Acha, Pramod sir. Pramod sir, for you.
It should be a screenshot. You can add a screenshot and add in that particular doc file.
Okay, sir. Thank you.
Yeah.
And sir, for Rathod sir, I want to ask you one thing. on Saturday
madam.
the exam will be in the form of MCQ or what kind of
MCQ.
Oh, thank you so much, Mohammed sir and Rathore sir.
Okay. Thank you, ma'am. No, sir, Chetna madam, those quizzes are hidden. We have hide them because people were getting confused which quiz to appear. They used to click on some other links. That those kind of things were happening, and we used to get some other messages. So that's why we have simply we Saturday exam timing 10 to 11. Yes, it is 10 to 11. Only hidden because those quizzes are over. No, but if you want, we can again show it. That's not a problem. Correct. Please appear for the exam. Appearing is very important. Parvez sir, I'll again call him. Just a minute, what happened?
Hi, I'm back actually. I'm very sorry. I'm extremely sorry because there was a power cutoff. So, can you hear me, guys?
Yes, sir. Yes, sir. You can.
Okay.
I'll give you your rights are also found. Just
Yeah,
I'll
sure,
check.
sure.
Yeah. Okay. Given, sir. You can continue.
Yes. I'm just sharing my screen. Okay. Okay, so I'm really sorry there was a power cutoff. So we'll start from where we actually left. Okay, so I think I was I I was I think here. Okay, so here what I did basically for balancing my data set, what I did, I took all the records of my minority class, that is of class 1, and a same number of records of the majority class, right? So now, and then I am concatenating both the data frames into one data frame, and I am shuffling that data frame, right? So here, like you can see, like I have a filter of class where the value is 1, and here I am having the filter for the class where is value 0. Okay, and I am taking only I'm giving 0 to 491 records. So basically, like in slicing, actually, when you give the end value, it actually take till -1, right? So this will take from 0 to 491 records, right? So this is how I am like taking balancing my data set. Then I am using a concat function of the pandas library and concatenating both the fraud and non-fraud data frame, and then I am doing a shuffle. So this I am taking a sample, I am seeing fraction of 1, that means 100% of records, and I'm doing a randomization of my record. So this is how I get my balanced data set. Okay, so now if I get the percentage, similarly how I calculate, I can see like my data set are now 50% balanced data set, right? So what I have done in this cell, basically I have plotted a heat map over here. So I'm using a heat map of my data frame, correlation between the data frames, the correlation between the features, and I'm this is basically like giving me the correlation matrix. This is actually pandas correlation object. Okay, so I'm calling a method called CORR, and I'm getting the correlation matrix into this particular variable. Okay, now I'm
plotting a heat map. So in the first heat map, what I am doing basically, I am taking my imbalanced data set, okay, the original data set which I had, right? So I am doing a correlation of my original data set, that is DF, okay. And in the second heat map, what I am doing, I am finding a correlation of my new data set that is imbalance, that is balanced data set, that is having 50 is to 50 ratio, right? So as you can see from this particular first heat map, there is hardly any correlation between the features, okay. So the data set which was balanced, which has 50 ka ratio, if I draw a heat map out of that, I can see that it has highly correlated data, that the correlation are actually good enough to actually predict my build my model on top of that balanced data, okay. So this is how I actually plot the heat maps. Going forward, so now I have a balanced data set. So my data set has 50% of minority class samples and 50% of majority class samples, right? So I'll be doing a test on these sample records, okay. So I'll be like creating a model using a logistic regression, okay. And I'll be creating my model using k nearest neighbor and support vector classifier and decision tree classifier. So using all these classifiers, I'll be creating my model and I'll be checking the accuracy of my models, okay. So let's go ahead and see the code for that, okay. So first thing first, like I am like splitting my input features and the output feature. So output feature is my class, right? So from the new df, from the balanced df, what I am doing, I am like splitting the class column from the columns, okay. And I am putting it in variable x, and the output variable class I am putting it in variable y, okay. So similarly I am doing the train test split, okay, as we did earlier, as I explained during the time of LDA, like we are doing a 80-20% split, right? So basically 80% will be my training data and 20% will be my test data, okay. So going forward, here I am like defining my dictionary. So this is basically dictionary of my classifiers, okay. So what here I am saying, like I am having a key and a value. So this is Python dictionary, okay. So in the value I am having an object of logistic regression. So similarly I have object of k nearest neighbor classifier object, okay. And then I have support vector classifier object, and then decision tree classifier object. So this dictionary I'll be using further to actually train my models on all these classifiers, okay. So here I am using for splitting, I am using cross validation score, right? This is another library which is very helpful in splitting your data into train and test, okay. So what here I am doing basically is I am iterating through all my classifiers. So basically, let's say I have four classifiers in my dictionary, right? So iterating through that particular dictionary, okay. So in my key column I will have key, and in my classifier variable I will have classifier. So in like first time when I get inside this particular loop, my key will have logistic this string value, okay, and my classifier will have this logistic regressions ka object, okay. So in the first step in the for loop, what I am doing, I am like calling the cross validation score, and I'm giving the classifier on which I want to train my data, okay. And I'm giving the train data like the input parameter and the output parameter, as it is like supervised learning, so I am providing the output parameter as well, okay. And here I am giving cv equal to 5. Now what this cv means, okay, I'll just explain you in a brief, okay. So So what happens basically when I say CV equal to 5, right? So let's say my data set has, assume like it has 100 records. Okay, so what this will do, cross validation score will do, it will split my data set into 5 subsets. Okay, so let's say I have 100 records, so each set will have, each folds will have 20 records in that. Okay, so each folds will have 20 records in that. Now what my cross validation validation does basically, at first time what it does basically, it takes this particular let's say these 4 folds to train the data, and the 5th fold it actually uses it for testing purpose. Okay, and in the second iteration what it does basically, it actually takes the this particular fold as the testing data, and the remaining this and this. Okay, so all these things it takes as a training data. Fine. So it will do a cross validation, it will run my model 5 times with the different set of testing data and the training data. Okay, so this is how my cross validation score actually runs, executes. So and each time it will have a accuracy score. So basically I am like taking the accuracy score, so it will return, this will return me 5 accuracy scores, right? As I explained you, like since I have given CV fold is equal to 5, it will divide my data into 5 partitions, and each partition it will use for testing, and the rest of the 4 partitions it will use for training purpose, and it will return me 5 accuracy score, and I will just take the mean of those scores, and that will be my like accuracy score for the particular model. So here you can see that my logistic regression model, which has been the model which has been trained on logistic regression algo, it has the accuracy score of 94%. Okay, and my k nearest neighbors had a accuracy score of 93.101%, and so on, right? So you can see like on the balanced data the accuracy score has actually the model has performed well, right? Now let's take the second method, which is synthetic minority oversampling technique. So as I explained you, in this method we actually generate synthetic minority class samples, and we actually do training our model on those samples. Okay, so in this, like we'll be using a library, the library called IBM Learn, and in that we'll be using an object called SMOTE. Okay, so the SMOTE object has 2 parameters. So the first parameter is k neighbors, and the second parameter is sampling strategy. So what does this k neighbor means? Basically what, as I have explained, like in the vector space or in the Euclidean space, what it does, it sees like the nearest neighbors, k neighbors, and it generates the synthetic sample for the minority class. So this is the parameter which it decides like how many nearest neighbors it has to consider while generating the synthetic samples. Okay, now second parameter is the sampling strategy, which is 0.01. So what does that means is like let's say I have a data set. Suppose let's say I have a data set which has like 1000 records of the majority class, and let's say I only had 10 records of the minority class. So if I say like this is just like I think this is just 1% of the majority class, right? So if in the parameter, in the strategy parameter, if I say let's say point uh, let me just check, it's saying 0.01. So let me say like if I say 0.1, so I am saying like generate 10%, generate synthetic records of the minority class such that the number of records of the minority class is 10% of the majority class. So what it will do, so since I have 1,000 records of majority class, what it will do, it will generate let's say 10% of this is 100, right? And I already have 10 records, so it will generate more 90 records, so that the number of records of the minority class is 10% of the majority class. Okay, so this is what smooth function does. Okay, so and also, like, what I am doing basically, similarly I am like undersampling my majority class. So what I am doing basically, I am using the random undersampler object of IMVLearn to actually undersample my majority class, such that the minority class sample will be 50% of the majority class. So what I will do in the previous scenario, like this case which I have taken, so I have generated 90 more records of the minority class, right? Now what I will do, I will undersample this majority class such that the minority class is 50% of the majority class. That means I will just take 200 records of the majority class, right? So my minority class will be just 50% of that majority class. So I am using random undersampler function to do that. Okay, so here is the code. So again, I'm like classifying, like I am splitting my input parameters and the output parameters. Okay, and then I'm actually creating an object called stratified k-fold. Now what does this stratified k-fold does? So let me explain that as well. Okay, so let's say in the cross validation, the previous object like which we created cross validation, and we specified like cv equal to 5, so it randomly generated 5 folds, and it split those into 5 partitions, right? But in stratified k fold, what it does basically, it maintains the ratio of the majority as well as minority class. So let's say I have 1,000 records of majority class and 100 records of minority class, right? So the ratio is like let's say 10:1, right? Okay, so what it does basically, when I use that stratified k-fold method, what it does, it generates is splits this data, my data set, into 5 folds. Since I am specifying cv equal to 5 fold in such a manner that each record will each partition will have the ratio of the majority and the minority class as 10:1. So my first partition will have 200 records of the majority and 20 records of the minority class. My second partition will have 200 records of the majority and 20 records of the minority class. So this is how, like, my stratified k-fold method actually performs. Okay, so I'm saying, like, over here I'm saying stratified k-fold split my data into 5 folds. Okay, and these are seeds for the randomization and shuffle. Okay, so this will do what I have explained you. So it will maintain the ratio of my minority and majority class. Okay, and I have already explained this mode function, what it does. So I have created an object called of stratified k-fold and of smooth, and then I am creating an object of random sampler, right? Random undersampler. So what this particular random undersampler does is, like, it will undersample my majority class ka samples. Okay, so it will undersample in such a way that my minority class is 50% of the majority class. What this sampling strategy means actually over here. Okay, so let me go ahead, and so I am like training my model on all these classifiers. So basically here I am using a pipeline. Okay, so in the pipeline I am specifying the steps which I have specified over here. So I'm having a list, okay, called steps. Okay, in this I have a list of tuples, okay, where I have the key. So this you can give anything you want, and this I have a value, right? So in this I am passing in objects. Okay, so here the objects are over, under, and my classifier model, which I am iterating through my list of classifiers. Okay, so here you can see that like I am creating a pipeline object wherein I am specifying the steps inside this. So pipeline needs a parameter as steps, so I am passing my list of steps inside this parameter. Okay, now I am calling this cross validation score, which actually we have seen. So right now in this cross validation method, I'm not passing the value. Previously we passed 5 as a value, right? In this I'm passing an object called sss, which has the object of stratified k fold, right? So this will execute the stratified k fold object, and the 5 partitions which the stratified k fold actually creates, it will run a pipeline on those samples, on those partitions. Okay, so here like for each partition it will do oversampling using smooth. Okay, and then undersampling using random undersampler, and then it will make my model run on that particular classifier, logistic regression and k nearest neighbor and support vector classifier and decision tree classifier. Okay, and similarly like the previous step, like how I was printing the mean of the accuracy score, whatever like the cross validation score return me. So it will return, like since I have 5 folds, it will return 5 accuracy scores for each of the classifiers. So I am taking the mean of the accuracy score over here and I'm printing it. So you can see like the previous balanced data set, which has a 50-50% ratio, like it has the logistic regression model had 94.03% of accuracy, and after doing like synthetic minority oversampling technique, we have seen that the accuracy level has increased by 3 to 4%. Okay, so this is how like you deal with unbalanced data set. So these are the techniques like used for handling the unbalanced data set, imbalanced data set, you can say. So all these techniques, like whatever we have discussed from yesterday till today, these are the major like basic pre-processing thing for the machine learning. So these are the most important steps in the machine learning world. So whenever you give a good data or a good dimensions to your machine learning, to your model to actually train on, the better results you will find actually. So these are the things whatever we have discussed till now. Do you guys have any questions or anything? uh, Guys, I'm actually done with the subject which we have to cover. So do you have any queries or uh, any questions regarding the session or regarding any terms that we have actually explained and actually learned in the session? Can anyone reply? Okay, so Dr. Nirbhay Chobe has messaged me saying, "Can you help me in uploading dataset?" Yeah, sure. Like, what's the problem you are facing? Can you just unmute yourself and speak out? So, Dr. Chobe, the thing is that in my code, like I've specified the path where I have the data, right? So you have to specify your own path. So if you are like running that in a Colab notebook, on the Google Colab notebook, you have to upload the file over there, and then you can directly actually use that. So I can give you a command wherein you can upload it directly from the Google Colab. Just wait.
We have done the same thing actually. We have mapped these data sets in C column. Data set one folder I have created. Within a data set I have created subfolder AICT, and
Hmm.
thereafter I have copied scaled credit
So,
card.chg.
are you using Google Colab?
Yes, I am using
So
Google Colab.
Google Colab will not have access to your local PC, right? So
Right.
you have to upload this data in the Google Colab.
Okay, just a moment. Okay, let me do it.
I'm giving you the command. Just wait. Just wait. Just wait. I will give you the command to actually upload it on the
Yes,
Google
sir.
Colab. So
Please.
I have somewhere on in my notebook. I just don't remember that command. Uh,
Files.upload. Yes. Thank you, Dr. Tanuja. We did it actually, in previous section.
ha ha.
Yeah.
So you upload it and then directly you give the file name. So you don't have to give C colon and all those things. You just give the file name.
Yes, I remember. Yes. We did it. Yeah. Thank you.
Okay. Okay.
Time to upload. It's a big file.
Yeah. It's a big file.
Thank you, Parvez sir, for an enlightening and encouraging session on coding dimensionality reduction in Python using PCA techniques. And also bonus topic is like imbalanced data. I
Yes.
hope uh, our participants are able to remove the redundant
Hello.
thank you, sir.
Yes. Thanks a lot. Thanks a lot for inviting me. And it was a great pleasure actually, like talking in front of teachers and professors. I don't like people are very much highly educated than what I am. So it has been like a great thing to actually speak in front of you guys. Thanks a lot.
Thank you,
So
Parvez. Thank you, Parvez, sir. Thank you very much for taking out the time for us. In spite of your busy schedule, you could manage 2 days evening.
not a
Thanks a lot.
problem.
Thanks a lot.
Pleasure. It's my pleasure. And in the last notebook, I have given my Kaggle link also, so you guys can actually go on and read that also. Basically, it actually explores more on the imbalanced data set. And if you guys want to just connect with me, like you can connect me on LinkedIn and all. So it was like great, like speaking in front of you. So I will just share my LinkedIn profile. So if like anyone wants to like connect with me, like I'm happy to help them. So thanks a lot. So I think we should call it a day.
Yeah. Thank you, sir. Thanks. Thank you very much.
Thanks a lot.
Okay, so participants, tomorrow we have Rocky. Our Rocky will be rocking tomorrow. You know, you had interacted a lot of interaction was there with him, right? So entire day tomorrow belongs to Rocky sir, morning to evening, and he has shared a collab link which I had already put on the Moodle, and I had already shared this link in the chat box also when we started the meeting. You can go back and see the chat box if you want. I can put it back here. Copy paste I'll do. Collab link for tomorrow because he has requested that you should come prepared with this link. So I'll put it here once again.
Okay, so bye everyone. Have a nice day. Thank
Yeah,
you.
Parvez sir. Bye. Thank you very much, sir. Thanks.
I'm not able to download the certificate. Can you help me?
No. That I'll be sending you, sir.
Okay. Thanks.
Yeah. Within 5 minutes, you'll get it.
Thank you, Rathod sir. Thank you.
Okay,
Thanks.
sir. Okay. Okay. Thank you very much, everyone.
Sir, I have not marked my attendance.
It is okay. ठीक है, madam. Actually, we have multiple ways of managing. This Cisco also gives us the records. It's okay. But don't forget to give the assignments on Moodle. That's it. That is most important. हाँ कौन वंदना मैडम
Yes, sir, I have a request. Can you extend the quiz timing which is there on Saturday? Because I have a lecture from 9:30 to 1 p.m. 9:30 to 1 p.m. I have a lecture. So can you make the timing like 8 to 11 or 11 to 2?
Madam, then entire class will be of inconvenience, no?
Because sir, it is very difficult for me to get at least 15 or 20 minutes to attend.
But that exam, madam, see, that exam is compulsory, no madam. What can I do?
Yes, that is compulsory.
Because we have to, no, and we have to also complete the everything in a proper manner, no?
Yes, sir.
We have to only see the eligibility.
Because sir, I have given all the quizzes and I have attended most of all the sessions also. So the last quiz I don't want to miss it.
Can you do the adjustment?
At least sir, no, it's very difficult to adjust the lecture because everyone is from group. That's why. Can you just extend the timing like in morning 8 to 11 also? Okay, I want just 20-25 minutes. I will finish the quiz.
I don't know because that was supposed to be a descriptive. We converted it to objective. Then
so please see to
multiple assignments. Okay, we'll see. We'll discuss among our organizing members what can be done. Okay, I'll discuss with them. On fly, I cannot give you answer. I'll talk to them because there'll be burden on that the last day also. No, it's that day will be validity will be busiest day for us, and doing all these juggleries will be a problem. That's it. Nothing else.
Even I don't want to miss it.
Yeah, because that's a very short period. We have to do assessment.
Yes.
We have to complete assessments, we have to finalize certificates, everything. Yeah.
Yes, between two lectures, no, I have only 10 minutes break. That's why.
You take it half an hour, madam, one day.
No, sir, it is monitored. No? Let me see to it if it can be done.
Do I say? Okay, we will see you tomorrow. We'll see what can be done. सोनी मैडम आहात का? मनीषा मैडम.
हॅलो, हा सर.
सोनी, ठीक आहे. मला वाटलं गेल्यात की काय. Then we can speak for 2 minutes. I'll other participants, you please can leave this thing. Our planning.
हो का सर?
2 मिनिटं थांबा ना, आपल्याला ते बघायचे आहेत ना एक दोन गोष्टी. 1 मिनिट, मला 2 मिनिटं फक्त, कारण परत फोन करण्यात काही पॉईंट नाही ना. वी आर ऑलरेडी
हो. सर तुम्ही पार्टिसिपेंट रिमूव्ह करा, मी 1च मिनिटात आली.
बरं, या लवकर.
हो.
End the screen also.